Then I think we are back again. I'm very happy to welcome Andrew on the stage. He will talk a little bit about how he is senior software engineer with Dynatrace, and he will talk a little bit about debugging Golang applications inside Kubernetes. So obviously he's building Golang applications, and we just had a short chat. He's mainly focusing on building operators in Golang. And yeah, obviously from time to time there are also some errors which need to be debugged. Happens to all of us, obviously. And yeah, I'm really looking forward to this talk because I'm very big into the topic of operators for Kubernetes and custom resources and all the stuff. So without any further ado, welcome on stage, Andrii.
Hey, can you hear me? Okay. So, I really am glad to present today here, first time in Vienna. Originally about me, I'm originally from Ukraine and now I'm working and living in Austria since war started. I do some open source contributions. I'm a big fan of debuggers. I did lots of talks previously in many conferences, and you can find some links on my blog and read some random stuff. But let's focus a little bit on development. So development is hard, and there are a few reasons why it's hard, because we have to keep in mind and focus on different contexts. Then we switch contexts, then we play with different abstractions, and it's really tough. And usually it's like every day you see the problem. My code like has no errors, but it does not work. But it didn't work like 5 minutes ago. What went wrong? I don't understand. And so yeah, usually I feel like I'm mostly spending on debugging rather than on coding. So this picture just me during my working day. So most of the time I'm debugging rather than like coding or thinking of something. And that's why I wrote, I inspired by these 8 stages of debugging from Reddit. I slightly change it and extend it. So usually I'm like, that can't happen. My second stage, that it doesn't happen on my machine. What goes wrong? That should not happen on my machine. It should work. Why does it happen? Oh, I see. I think I know. I know how to fix it. How did it even work previously? Oh, who wrote this shit? I think I know. Oh, wait, it was me. So, yeah, there. From another perspective, there's many books about programming, about cloud native, Kubernetes, blah blah blah. But there is no books about how to debug. Since we spend 50% of time on debugging, but we don't have books, posts, or even in Google, if you try to dig into this problem, you will not find lots of resources. That's why I try to share my experience on this talk. Okay, question to you guys, so you a little bit be more active. How can I debug my Go program? Any ideas? You can raise a hand or you can just shout it to me. Yes, nice. Thank you, Marcel. Yeah, you can just print. Yeah, you wrote the code, you can print, you add as many prints as you can, and it's valuable approach. Second approach is probably we are logs. Like we are often like run logs and see grab something. Maybe we can find an issue. In Golang there is playground. You can probably run some small snippet and try it out. Yeah, but it's not ideal, of course. But my favorite one is Duck debugging. You know this approach? Raise a hand who knows this approach. Yeah, it's also my favorite one. You just try to talk with fake duck. It's not even real duck. And you try to explain to this duck that here's the line, do this. And suddenly you can realize that, okay, I figure out how it should work, and you can fix it. But of course, we are more serious engineers here, so we can use more advanced tools. So today, and it's a good point, just let's focus only on debuggers and how we can use them, assuming prints not works, logs show nothing, and yeah, we are inside Kubernetes. So that's why I assume all of you knows how to debug code, not only in Golang, but in general, how to debug it using just like run it locally. But because we are in Kubernetes and we have lots of constraints, for instance, it's at least we build an image, we deploy it, and we run it. So I will focus more on how to debug it first in containers, so just to make some groundwork for next more advanced steps. So very famous debugger, I'm not sure who of you knows or not, there is a Delph, it's Golang debugger. You can read on it about later, or you can just I can quickly explain. It's just CLI tool which can connect to your running binary or can compile it and run it. I will show you in a few seconds. So you will understand it by practice. And it works only because Go produces dwarf. It's a like standard, like we love other standards, is a standard of debugging format. So different debuggers can debug different like programs just because of the standard. For instance, you can use not only Delph, you can use GDB, for example, but it's another story. But it should also work. Okay. And of course, if you suddenly disable this dwarf generation to reduce some image size or binary size, and then image size, of course, it can be harder. So make sure you not remove this flag when you want to debug something. Okay, and now let's more focus on real world examples. So I created this Docker file, which I mean very straightforward. It just has we download Golang, we add some code, we install dependency, and also we install debugger. So this image already includes debugger, and on entry point we start shell. And yeah, the difference is just debugger inside. So our case when we debug when we build and we back in debugger into our image. And I have quick demo. I hope it can work. Will not break anything. Can you see my screen? Yeah, I think you can. So I already build I already built this image just to save your time. So what I'm doing, I'm running this image and it puts me to the shell. So here's your debugger. You can even check help, blah, 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 etc. So, and first thing first, so Delph debug helps you to debug your current like Golang package, which requires only package inside. So if you check, we have this hello world inside Docker. So if we run it, it should work, I hope so. And we set breakpoint to the main. Yeah, and I hope you can see it. We stop on the main function, and you can just go next, print variables, do some stuff you need. Of course, you can do it from UI if you want, but because we're inside Docker, it's just there is no UI. That's why it's handy when you know how to use CLI debugger. Yeah, yeah, you can restart it, restart your process. You can set again breakpoint. You can list your program. So you can do different stuff. since, I don't know, maybe year and a half or 2 years, they added like you can call some functions. For example, you can call, I don't know, quote hello. Oh, it doesn't work. Yeah, and that's it. But the reason of this use case is just we have Docker image, we bake debugger, and we add source code, and we just run shell. But it's not the case how we usually do it on production. And yeah, it's just repeating what I showed in case if it goes wrong. So yeah, on production, usually we do multi-stage Docker images, which slightly different case. I have example for you. So usually we have one layer which build, compile our program, and then we copy it to another layer as a binary, and we run it, and we don't have anything inside, and it's not so easy to debug like I showed, but let's try to do it. Maybe we can do it. The only extra tool I added to this like final stage, I copied debugger binary also to this new layer, so it helps us to do the same like trick as we did before. So let's try. I have another demo. I hope it should work. But now you can see there is no Go, nothing. It's just only like app binary, which I hope should work. Yeah, which just prints some shitty information. And we have a debugger binary. So, but anyway, we can use an exec, we can connect and run this binary, and we can also debug it. I'll show you. So same trick. We run it, we set breakpoint, we click next, next. So it works, but probably you can see there is no, so it's not readable. We don't see source code. We know nothing. We like, okay, there is no hello.go. How can we fix it? Because it's like not fun to debug it in such way. You like, okay, I know you can set breakpoint on the line, or you can set breakpoint on the function name, as I did. Like, I didn't explain it, but main means package and then function. Yeah, let's try to fix it. And to fixing it, we can do a few tricks. So yeah, Delph itself has config file, and we can fake a little bit our sources. We can substitute paths, and instead of using like Docker image path or original one, we can just using my local path, which helps us to debug it properly, and it can solve the problem. But better I can demonstrate it on another demo, just to not repeat myself. So there are also a few words a little bit about configuring Delph. You can list all options. We are reading YAML file, or you can just print config-list inside debugging session, and it will print your all options. One interesting option you can change is the length of the string output, because from time to time, if you print some long strings, Delph will make it shorter, which is not useful sometimes. And yeah, of course, if we're using this multi-stage Docker file, and of course, as a result, Docker image, which does not include source code, of course, if we add source code, but why we have multi-stage? You can, one can say it doesn't make any sense, Andrii. And here's what we can do with remote debugging. So when we run our program and debugging session like using this both client and server, but we can run Delph in separately, like we can run it headless and we can connect to it. So yeah, I will make a small change in my Docker file. I hope you see this not ideal diff, but the idea is this line. So instead of running our app in multi-stage, just let's run Delph, like listen on the port, and the important is like headless true. And here, as you can see, same trick I did, Delph exec and binary name. So it will give us to the next demo very quickly. I think next one can be more interesting. Live demos is always risky, a little bit. Let's try how it goes. Okay, now. So what I've done, I already built an image, which let me show you very quick. Which has this headless, and you can see logs from Delph. So we are running like Delph headless in the container on this port, and that's it. So nothing else. And now let's connect to this port, and let's say set a breakpoint. So now we see that like debugger start printing some logs, which means we set a breakpoint, and let's click continue. Wow, and now you see it works. So from my local machine, I run Delph client, and inside Docker image where we're running Delph exact binary, we are connecting and we're setting breakpoints, so we can go and next, we can like print, we can change variables. Usually what you can do with debugger, conditional, breakpoints, everything. And interesting that you can, since it's in Docker, it's useful, so you can restart it. For example, no need to touch anything like Docker run, so it's running forever. But if you restart, you will start from scratch, so you can keep all your breakpoints, but you will start program until you sequentially debug the part of the code which you assume has a bug. Sometimes it requires few iterations until you find exact place of problem. So now we have all groundwork we need to understand more or less everything, which requires us and move forward to Kubernetes. So we just did it in Docker locally. We did it, we connected. As I told you, like, does it work? Oh, okay. We fixed also sources. On local machine, I set like substitution path to my local source code, but I'm debugging like binary inside Docker. It knows nothing about my sources, but it should be same version, otherwise it will break. And we can like debug it as usually using Delph Connect. Something I broke, I think. Yeah. Also, you can do the same trick with another runtime like Podman. Locally, so I tried, will not waste time right now, but you can also build image with Podman using same more or less files. I created a repo, so you can, after talk, you can check out it and try all different variations on your own, and it will help you to like learn and maybe adopt it to your own project. But returning to Kubernetes, it's fun, but it doesn't work anymore. my slides. Oh, I think I fixed it. Yeah, and returning to Kubernetes, of course, it doesn't make any sense to every Docker image you have in the company to change um, like how you run it or like even update it. So I have this entry point, which what it does if you have environment variable set it, so it means we want like debug mode, and we will run our binary with using Delve, so we can connect on it. Or if there is nothing, like no environment variables, we just run binary as is without any Delve. And it helps us to play with some Kubernetes environment variables and turn on or turn off it very quickly. Yeah, and instead of just like running this line, which you can see in the very bottom, I think it should be, yeah, here. We just created entry point, we copy it, so two modifications to your production Docker file is, yeah, of course you need Delve debugger inside, and you need this entry point, but anything more or less looks okayish and secure, so you can use it even on production. Yeah, and here's my like example of the pod which I used for debugging. So assuming I have this application, yeah, assuming I have, yeah, I think I lost my back button, doesn't work. Oh, I think I fixed it. Nice. So yeah, looks like my keyboard is gone. Okay, so no more demo, unfortunately. Yeah, can we turn off it for a second? Yeah, it's super weird. Yeah, anyway, I will just go forward. So assuming you have this environment variables set up, and if you apply it to your cluster, and then you have few ways of doing. Unfortunately, I can't go back, but it should be there. So, and then you can tweak these environment variables. And the question is, do you have access to your cluster directly from your local machine from network point of view? So can you expose this port? Maybe it's not secure, maybe it's VPN or etc. So the first straightforward way to do it is by port forwarding, and just same trick as I showed, using Delve Connect from your local machine and debugging it. Another idea is to, if you don't have the success with port forwarding, you can use this kubectl debug trick, which gives you ability to run another container and share processes to your like main one. And because this kubectl debug will guarantee that you have like network between, so you can like add source code to this image, add delf also, and you can connect to it and run like also debugging session, but it will be inside Kubernetes. Like you will have one pod which running your app with delf and another pod which running like your I think I have slide, but yeah, here it is. Yeah. So another one is a debug one, and from this debug one, you like doing this live session of debugging, and you can debug it even in very secure environments. You just need to have this image, which, for example, in my case, it includes already delf in both cases, but in your case, it can be one has no source code, another one has source code, so it will simplify you debugging a little bit. And since it share processes, it's just demo on the slide. You can see I run PS, so I see that on one container we run like headless delf with exec application, and on another pod we run delf connect, and then we can yeah, it's not here. And then we can debug, and you already saw it. It will be one-to-one what you already saw. You can restart it, you can stop it, you can do different tricks. So it can help you to identify the problem. I found it very useful, and it really helps to identify very weird issues which you can't reproduce locally because of, especially if you're running operator, it's not easy because locally you don't have everything you need. But important note, you have to burn your git commit SHA into your Docker image, because when you trying to debug, you need to find or prepare another image with the same version of source code. So when you substitute passes for delf, it will properly like replace it, so you can debug it and visualize how you do it. Otherwise, if someone, I don't know, rename files in one commit, and you will try to use this commit to debug, you will screw up delf, so it will jump to different location. And as I already told you, when you build your binary, Golang like adds this dwarf information, which includes like line numbers, files, etc., all metadata that debugger can understand and can use when you like use this debugging session. Yeah, of course, lots of people already showed you this trick, like when you're running this K8s. Just raise the hand who is using it nowadays. Okay, so it's just terminal UI for whatever, connect to Kubernetes, see pods, and namespaces, I don't know, logs, etc. And this tool, not everyone knows that you can configure this tool, and it has plugins. And I added plugin to my K8s, which can add this debug pod dynamically. For example, you can see I have a hotkey, and I can add debug container to select it. So these variables of K8s documentation, it's like selected namespace, pod, blah, blah, blah. And I use this like very standard image with networking tools, but you can replace it with your application code and same share processes, and for example run bash if possible. So, and you can very easily spin up such like containers, debug stuff, and remove them. So there's a bunch of other configurations of K9s you can find in docs. You can totally change UI, columns, hotkeys, plugins, and other interesting stuff you can find on your own. So yeah, a little bit summary since my keyboard doesn't work anymore. So yeah, keep in mind debugger does not fix your bugs; it just runs them in slow motion. So you have to fix bugs. Also, don't forget to add some details to your images. From debugger, you can find like Golang version, etc., but you can't find like, for example, Git information or commit version. So you are responsible to adding it, because if you're trying to debug random binary which you don't know the source code, it can be very tough. Of course, you have to scale your traffic down, because if you're debugging this pod and this pod like receives lots of requests during your debugging session, you will have, I call it like misses, because it will only stops on first requests, but then debugger reacts on another request and your previous debugging session gone, and it looks very strange. So as much as you can, like, scale down so you have only one pod and another debugging pod, and try to limit requests. Of course, use debuggers as much as possible. I found in my career developers usually trying to assume, or like I call it predict bug, or like I think maybe it's because of this, and trying guessing like entire day instead of just quickly debug it and see that, I don't know, there's like a bad symbol in inputs, and fix it in like 5 minutes. Of course, automate routine if you need to more often, I don't know, introspect your running pods, or for example get events of your pods. You can do it with K9s. You can tweak it on your own and just make your developer experience more robust. And for future reading, I have few links. Yeah, there is very nice architecture diagram of the Delph from the authors of the Delph on the slides. Also, they have like lots of theoretical basis how to write debugger. It's very interesting reading, highly recommend. Yeah, you can check this dwarf specification, check a little bit why GDB is not good for Golang. It's not properly understand runtime and other limitations. Yeah, and last but not least, we discuss only like debugging running pods. So you can also find how to debug pods which you can't schedule. It's another problem, but I assuming that like your code at least running. So you run it, it's running, but it has a bug. There is a good article how to find like which Go version built into your binary. It's very interesting finding, and yeah, there are like few ways how you can add this commit. So you can also check it out. Yeah, questions?
First of all, thanks a lot, Andrii. I think it's also time to give you a little bit of applause before we jump into the questions. So are there any questions?
So you can think about questions, but you can download slides, and I will share repo where like bunch of examples which I used for this presentation, and you can use it on your own. Yeah.
on your own pace.
Yes. And
Cool.
if you want to observe how it works on my machine using kind, I will show you after talk. I'll just reboot and fix my keyboard because my keyboard is gone.
So any questions in the meantime?
Oh, it's returned back. Oh,
There's one question.
I probably can show you demo. Maybe. Let's try. We have a couple minutes, right? Okay. Yeah, I have sample app, and it's running debugger inside. Oh, now you don't see it. And let's port forward stupid way, and yeah, to make sure that it's me, I will jump from time to time to the logs. And now since we port forward, we can connect to inside Kubernetes. I'm using kind just for demo, and you see it's same as it was before. And again, you can debug it as I showed before. It has version, by the way, and other stuff. And interesting fact, which I found very useful. So you can restart it without doing anything with Kubernetes. Kubernetes will assume it's running because now Delve manages this process. So it will restart it, and you see it will restart it, and you can again debug. So it's very handy in like different environments, or when you need restart it. No need rebuild the image, no need to do anything. You have Kubernetes, you have binary, you open a port, you connect, and you enjoy. So that's probably the demo. And yeah, I will share a repo, so I think it can be very handy because you can use it. Yeah, so here's a repo. So
cool. A few weeks ago, I was at a conference and somebody said this famous quote. At least for me, it sounded famous back then, where he said, "You don't need to debug if you do test-driven development," right? So
sorry, what?
You don't need to debug if you do test-driven development. So I will probably connect you.
Okay.
But I think the truth is somewhere in the middle.
Yeah, we should say to this guy, "Hold my beer."
Exactly. But there was one question, huh? I think. Yeah, let's take this one quickly.
Yeah, I've got a question. So a typical Kubernetes application is actually usually a distributed system itself, right? You've got a controller, for example, or you have an HTTP server, and they rely on a given state of, say, informers, which are kind of controls themselves. How do you deal with that in debugging?
You mean how to run a process which has its own arguments?
No, I mean how to run a process that is also dependent on the state around itself, on the state of Kubernetes. Like for example, you have 5 different informs, so which each represents a cache, right? And you want to debug your application in a given state where the caches are somewhat populated.
That's why I'm running it inside Kubernetes instead of locally, because I already rely on Kubernetes a lot. Because yeah, this is dummy example with like printing some stuff, but usually it's something which import Kubernetes controller runtime, do some stuff, and I usually debug it. Sometimes source code of this Kubernetes Go client or something like it. I mean, that's why we are running it. So same manner, run your app, run other stuff or assume it's running, and try to catch this case if you can. But if it's more event driven or with queues or other stuff, I would not recommend to do it in Kubernetes. I would recommend it to somehow to isolate it and try to do it locally. Because as I already said, I use this trick not every day. It's huge overhead. I use it only when I rely on Kubernetes. Like when I don't understand why it does not work in the cluster, and it works like locally, for example.
Did this answer your question? Okay. Cool. Then I think, unfortunately, we don't have any more time for further questions. Thanks a lot, Andrii, again for your great talk. Thanks again also for your live demo. Also, it's the risk that not everything works. Still, I mean, lots of thanks for that. It's always very entertaining to see people who hit the keyboard live. And yeah, with that said, let's jump directly nearly to the next talk. Feel free to switch the room if you need to. And thanks again.